Find the quotient 2 plus 3i over 1 plus 2i. So I'm going to show you how to do this by kind of putting the answer in general form and then doing a multiplication and comparing coefficients. Later on, or very shortly later on, I'll show you how to do it by using the complex conjugate. But in this one, we're just going to express it like this. So 2 plus 3i over 1 plus 2i. So we're dividing one complex number by another. So we know the result is going to be some complex number. So it's going to be a real part plus an imaginary part. So if you're looking for general complex number, z is often the symbol used to denote a complex number. And if you just want to give it a general real coefficient and the same for the imaginary, you're just going to call it a plus bi. So we're saying the general complex number z is some real part plus an imaginary part. So we're going to let this equal a plus bi. We're now going to multiply, compare the left-hand side with the right-hand side, and then we're going to be able to find out the values of a and b. So that should mean that 2 plus 3i equals a plus bi multiplied by 1 plus 2i. 1 plus 2i. Okay, so if we just do the multiplication, remember it's a simple FOIL. So 2 plus 3i equals, when you've got a times 1, it's just a. Then you've got a times 2i, which is plus 2ai. Then you've got bi times 1, so that's plus bi. And then you have bi times 2i, which is plus 2bi squared. So we need to be a bit careful with this I squared. Remember, the whole of the complex number system is based around one key principle, which is this. I squared equals minus 1. Everything else comes from that. So we can now do a bit of simplification on this. So 2 plus 3i equals a plus, and I could put these i's together. So if I just pull an I out of there, you've got 2a's plus b, 2a plus b I, and then we've got plus 2bi squared. So I squared is minus 1, so this is minus 2b. Okay, so now I can rewrite this again, and I want to clearly split it into a real part and an imaginary part. So 2 plus 3i equals, well, you've got the real part is a minus 2b, a minus 2b plus 2a plus b I. So now you can equate the real and imaginary parts on the left-hand side and the right-hand side. So there must be exactly the same amount of real component on the left-hand side, e.g. 2, as there is on the right-hand side. So equate real part. I'm saying equate, it's either side of the equal sign. So on the left-hand side we have 2. 2 must equal, on the right-hand side we have a minus 2b. Okay, so that's not quite enough to find out a and b straight away. It's looking like simultaneous equations. Now we equate the imaginary part. Great, the imaginary parts. So on the right-hand side you have 3i, so 3 equals, and on the right-hand side you have 2a plus bi. 2a plus b. Okay, so now we are going to form and solve our simultaneous equations. I'm just going to rewrite those in the most conventional way. So equation 1 can be a minus 2b equals 2. A minus 2b equals 2. And equation 2 can be 2a plus b equals 3. So we want to make the coefficient of either the a or the b the same. So I'm going to do it with with a. I'm just going to times this by 2. That would say 2a minus 4b equals 4. So then if I just look at these two, I want to combine those. I'm going to subtract. So 2a minus 2a is nothing. b minus 4b is 5b equals 3 minus 4, which is minus 1. So if 5b equals minus 1, then b must equal minus 1 over 5. So b equals minus 1 over 5. So we need to substitute to find a, and you can substitute into any equation you like. I'm just going to use the top one. So a minus 2b equals 2. So a minus 2 times minus 1/5 equals 2. A minus 2b equals 2. Depending on how you feel about adding and subtracting fractions, your next step will be impacted by that. I would probably just multiply everything by 5, so times by 5 to get rid of that bit. So that would be 5a minus 2 times minus 1, so minus 2 minus 1 equals 2 times 5 is 10. So 5a plus 2 equals 10. Okay, so that means 5a equals 8, which means a equals 8 over 5. We have been asked for the value of the quotient, as in what is the answer to 2 plus 3i over 1 plus 2i. So 2 plus 3i over 1 plus 2i. Well, remember, we said it was going to be an a plus bi. We've now just worked out the value of a and the value of b. So a is 8 over 5 and b is minus 1 over 5. So it's 8 over 5 minus 1 over 5i. Okay, so that is our answer. We can check that using a calculator. So make sure you're in the right mode. So we go to Shift menu and go down to complex mode. So I'm already in a plus bi, so that's fine. But if it's very unlikely that you'd be in that mode usually, so you'd normally be in real. So just make sure it's in a plus bi, and then just type it in. So 2 plus 3i, 2 plus 3i. Remember, I is down here, just above the 0. So Shift 0 over 1 plus 2i, 1 plus 2i. And that gives us an answer of 8 over 5 minus 1 over 5i. And you could get that in decimal form as well.